Before introducing IPv6, let us talk about IPv4. Despite the 4 in the name, IPv4 is actually the first version of IP to be used. It was launched all the way back in 1981, and even today, it's still the most well-known version to identify devices on a network. The IPv4 uses a 32-bit address, which is the format that you are probably most familiar with when discussing an IP address. This 32-bit address space provides almost 4.3 billion unique addresses, though some IP blocks are reserved for special uses. This is a list of countries by IPv4 address allocation as of 2nd April 2012. There are over 4 billion IP addresses in the IPv4 protocol. Of these, almost 600 million are reserved and cannot be used for public routing. The rest are allocated to countries by the Internet Assigned Numbers Authority via the regional Internet registries. From the list, we can see that some countries have run out of available IPv4 addresses. An IPv6 address is a 128-bit alphanumeric value that identifies an endpoint device in an Internet Protocol version 6 network. IPv6 is the successor to a previous addressing infrastructure IPv4, which had limitation IPv6 was designed to overcome. Notably, IPv6 has drastically increased address space compared to IPv4. The Internet Protocol is a method in which data is sent to different computers over the Internet. Each network interface or computer on the Internet will have at least one IP address that is used to uniquely identify that computer. Every device that connects to the Internet is assigned an IP address, which is why there was a concern with the number of IP addresses in IPv4 and why the Internet Engineering Task Force defined the new IPv6 standard. IPv6 uses 128-bit addresses, theoretically allowing 2 to the power of 128, or approximately 3.4 times 10 to the power of 38 total addresses. Each person is expected to be allocated 1 million IPv6 addresses. Countries that currently enforce IPv6 include Malaysia, India, China, and Brazil. The regulatory unit in Malaysia is CEREM, and the regulation is MCMC and TSFB-TC T013_2019. The regulatory unit in India is TAG, and the common regulation are as follows. The regulatory unit in China is SRRC, and the regulation is as follows. A backbone or a core network is a part of a computer network which interconnects networks, providing a path for the exchange of information between different LANs or subnetworks. A backbone can tie together diverse networks in the same building, in different buildings, in a campus environment, or over wide areas. Normally, the backbone's capacity is greater than the networks connected to it. Here are some common product definitions. There are several router types. 1. Core router. Core routers are usually routers used by service providers and cloud providers such as AT&T, Google, Amazon, Microsoft, and other companies. Additionally, core routers may be required for large enterprises if their employees work in different buildings or locations. 2. Edge router. Edge routers are also called gateway routers. Some people also call them modems. They usually do not have Wi-Fi and network management functions. Their main function is to connect to other networks or routers at the boundary point of the network to transfer data, sent to general users. 3. Distribution router. Distribution routers usually receive data from edge routers through wired channels and then distribute the data to designated IP addresses. The distribution method is mainly to connect individual devices through Wi-Fi, but physical connections can also be used to connect routers and internet-connected devices. 4. Wireless router Wi-Fi share. Combining the function of edge routers and distribution routers, common Wi-Fi routers at home are wireless routers. Most internet service providers will provide standard wireless routers. Still, if your network usage is relatively large, such as small enterprises or public places, it is recommended that you use an enterprise router to improve the connection quality. There are 2 switch types. 1. Layer 2. Package exchange based on media access control address. 2. Layer 3. Package exchange based on IP address. Access point is a gate to wide area network, a connection between wired and wireless network. Test definition. Host versus router. Hosts do not have routing ability. For example, L2 switch, enterprise Wi-Fi AP, PC, notebook, cell phone. Router has routing function ability. For example, IPv6 router, L3 switch, consumer Wi-Fi router. Routing is the process of package path selection in a network. There are 6 types of equipment for Malaysia MCMC requirement class. Consumer or enterprise application, host, network element, and network security element. There are different requirements for each type equipment class. RFC 8200 is the common requirement for all kind IPv6 device. RFC 4861, 4862, 1981, 4443 are additional requirements for enterprise devices. India IPv6 requirements are based on device application. For example, the first tag is the requirement for 2.4 GHz and 5 GHz Wi-Fi devices. The second tag is the requirement for IoT gateway devices. This is the simulated environment of IPv6 test topology. Test software will create TN1 TL TN4 and TR1 TL TR3 simulators. If device under test is a host, it will be endpoint of topology. Please see the right below. If the device under test is a router, it has to connect to link A and link B network. Please see the right video. These are definitions of IPv6 proprietary. TR means test router. TN means test node. HUT means host under test. NUT means node under test. RUT means router under test. Node is a device implements IPv6 function. Router is a node that forwards IPv6 packets not explicitly addressed to itself. Host is a node that is not a router. Spartan is able to execute IPv6 test of RJ45 Ethernet 10/100 1G megabytes per second and Wi-Fi 2.4 GHz and 5 GHz interfaces. This is an example IPv6 test cases list. There are hundreds of test cases. Each requirement will define which test cases a specific device category needs to comply with. This is a detail of an example test case. The The test software will send test messages to the NUT. NUT should reply with IPv6 messages. The test software will check whether the received packet conforms to the standard format. There is an easy way to check whether the connection is IPv6 or not for SRRC. Connect it to the website. The website will show the connection status of IPv6. When the IPv6 is connected, the number will turn to green light and 10 points. This button has been recognized by the Malaysian government and TOF as an IPv6 testing laboratory. Now we can perform Malaysian IPv6 testing and India Tech's IPv6 pretest.